Yes, Rahul sir, let's start.
Yes, sir. Hello all, welcome to the IIT Gate classes. So today we are here to discuss the solution of memory-based questions which we received from the student regarding GATE 2024, right? So here first of all we would like to see you know uh, exam analysis on the basis of some question which we got, and what are all the expected cutoff, what can be the rank, you know and what can be the rank based on the marks as compared to the last year, right? So we will take the reference not 2 3 years ago. We will take the reference last year only, and we will try to compare it, right? So here in GATE 2024, uh, before proceeding to the questions, what we can do, we can discuss here the paper analysis. So here paper analysis, if I do, just a moment. Here, guys, if you see, there is a section one, right? So here I'm doing the small, analysis. On the basis of that, you can, judge the paper whether it is tough or moderate or easy, right? So I will be taking section wise here. So here I'm taking section one. Again, in the section one, I'm taking the engineering mathematics. Engineering mathematics. In the engineering mathematics, guys, some of the questions that they were asked from the linear algebra, calculus, differential equation, complex variable, numerical method, and probability statistics. So all this section or whatever the topic they have mentioned, all the questions are there from that. You know, and the level again regarding section one, engineering mathematics. The faculty will discuss separately about this particular section. But according to our analysis, what we are getting is that the paper is basically, you can say, some of the questions are easy, some of the questions are like moderate, and some of the questions are like on the tougher side, like moderate to tough. So overall, you can say the section one is moderate. Again, I'm mentioning some of the questions are easy, on the easier side, right? That you can do when you are having the regular practice on engineering mathematics, right? Again, you can see the section 2. Section 2 basically is nothing but applied mechanics. We'll discuss some of the question also, you know, to basically clarify or to basically see whether what are the levels of those questions, right, in the respective sections. Applied mechanics and design. Applied mechanics and design, in this one, engineering mechanics. Again, three questions were asked. Mechanics of material, this time less question, basically there from the strength of material, but all the questions are from the regular pre-IQ based question. And coming to the theory of machine and vibrations, some good numerical is being asked from the vibrations, and some questions are good from the theory of machines. So overall, theory of machines and vibrations, making this section 2 little bit on the moderate side. Otherwise, the question is from the, all the questions are easier side only. So, and when you consider the design, in this one there is a machine design also, and machine design weightage is little bit higher, on the higher side as compared to the last year, right? So again, you can say a theory of machine and vibration. Because of that, you know, if I keep it like category, so it is again moderate, right? Then again, section 3. But again, in the applied mechanics and design, vibration questions and some of the theory of machine question, you can keep it on moderate to tough side, right? They are not very straightforward. Coming to the section 3, there is a fluid mechanics, fluid mechanics and thermal science. Fluid mechanics and thermal science, guys. Here we have the fluid mechanics. Again, 3 questions were asked. One question is a very good question on a pipe network, and remaining 2 questions are on the easier side. Coming to the heat transfer, again they asked 4 to 5 questions, and all are very good question. You know, all are basically very good questions. And they are based on the previous year based pattern, except one question which is on Fourier law, right? Then again, thermodynamics, 3 questions were asked. All the 3 questions are doable from the second law of thermodynamics. And again, we have the thermodynamics and applications. Last year, only one question being asked, and you can say almost like a zero question from the application. Only compressible flow has been asked from application part. But here, if you see the thermodynamics and application, this time they asked 4 questions. So again, they have increased the weightage on thermodynamics and its applications. Like they asked the question from the Rankine, they asked the question from the gas turbine. You know, again they asked the question from the compressible flow, and so again these are the questions they have asked. Again, there is a no question from the hydraulic machines. This time also there is a no question from the hydraulic machines. Similar like 2022, where we have found nothing from the fluid machinery, right, or from the steam turbines. So overall, fluid mechanics and thermal science, you can again keep it to easy to moderate side, right? Again, if you take a section 4, materials, manufacturing, and industrial engineering. Material manufacturing, you can keep it like moderate. The questions can be doable. They are all from the previous based pattern only, right? But if we talk about only industrial part, you can keep it like in a tough category. Again, questions are not that tough, but lengthy. You know, questions are very lengthy that we need to find initial basic feasible solutions from the transportation. Then we need to find the optimum solutions. So those questions were lengthy, and some of the good questions from the simplex method. So again, industrial engineering, that is only section where this ISC Bangalore has reflected its particularly you can say that level. Apart from it, in other sections, all are based on the what a previous year based, or whatever the regular question which we used to do in our classes, right? So that is all about the paper analysis. Overall, the paper is you can say on a moderate side only, and you can keep it like moderate to tough, right? Again, regarding the cutoff, after discussion of the questions also we will discuss further. But overall, based on the questions what we have received, so based on we can say the cutoff will be it will be around only 30 marks. You know, this would be the marks. Again, I will be discussing about the rank on the basis of marks, but after discussing the questions. After discussing the questions, right? So before moving to the rank part, we will discuss some of the question, guys, right? So here we will discuss question from the core subject. Now this is the section B, guys. Here section A, section B. In the section B, again we have the section 2, 3, 4. That is what we are discussing, right? So you can see the first question from the fluid mechanics here. Here, guys, you can see this question number 1. The velocity flow field of a two-dimensional incompressible flow is given as V is equal to 2 sine hxi plus V of x and y j cap, where I and j denote the unit vector in x and y directions. If v of x at y is equal to 0 is cos hx, then what is the v of x equal to 0 and y is equal to -1 is what? Right. So what the velocity field they have given? 2 sin hx I cap plus v of xy j cap, where u component is 2 sin hx, and what is the v component? It's a v of x and y. They have mentioned very clearly the flow is incompressible, right? For incompressible flow, what is the necessary and sufficient condition, guys? Volumetric strain rate has to be 0. That means del dot v has to be 0. That means what we can write, dou u by dou x plus dou v by dou y plus dou omega by dou z should be 0. But we have mentioned very clearly that for a 2D incompressible flow, that means omega will be 0. That means the jet component of velocity is 0. So dou omega by dou z or dou w by dou z will also be 0. So here we can write dou u by dou x plus dou v by dou y, that is equal to 0. Now what is the dou u by dou x? 2 cos hx. So this will be 2 cos hx plus dou v by dou y is equal to 0. What is the dou v by dou y? Minus 2 cos hx minus 2 cos hx. This is the value we have, guys. What we will do, we will try to integrate it. If we try to integrate, what we can get? We can get minus 2y cos hx. Now, whenever we are doing the integration of any partial differential equation, we need to add not constant. We need to add some function, and this will be the function of x. They have given the boundary condition. What is the boundary condition? At v x comma 0, the value is what? Cos hx. So put that value. When y is equal to 0, v is what? Cos hx. So that is the value of f of x. Keep the value of f of x back to this equation. Minus 2y cos hx plus cos hx. So what the value you are going to get, guys? When you put 0 comma minus 1, that means when x equal to 0, then cos hx, cos h of 0 will be 1. Then what is the y value? It's a minus 1. So minus 2 minus 1 into 1 plus 1. So what is the value, guys? The value will be 3. So that is the answer. Again, if you see this question, continuously they are asking this question from the past 3 years. A regular pattern is there behind this question, right? So again, you can see that previous year based and the previous year questions, we need to solve it to get the good marks in GATE rank in the GATE examinations, right? So that is a question one, that is of the fluid mechanics, right? Coming to the next question, guys, here you can see the compressible fluid flow. Try to observe this question, guys. Consider a compressible flow in a converging divergent nozzle. Which of the following statement is correct? In the converging portion and then from the divergent, this is the, we can say the convergent portion up to here, and then we have here to here at the end we have the divergent portion, guys. Divergent portion. What you can understand very clearly that the shock waves are forming in the divergent portion, and that is quite obvious. That is a quite obvious, right? Because in the convergent portion we cannot have any shock formation because Mach number is less than 1, right? Suppose we have started with the Mach number less than 1, here Mach number equal to 1, here we have Mach number more than 1. So what is the sufficient and necessary condition for any normal shock wave to be formed? There should be flow, inlet flow should be supersonic flow, and that's why it is happening in the divergent portion. Now, before discussing the normal shock, what is the normal shock? The shock wave that occurs in a plane normal to the direction of a flow. This is the direction of a flow, and perpendicular to it, whatever the shock wave will be forming, that is called as normal shock. And normal shock is basically highly irreversible phenomena. What is this? Highly irreversible phenomena. The moment you know this particular fundamental thing that it is one of the highly irreversible phenomena, then definitely you can answer D. That is, whenever we have irreversible phenomena, definitely entropy will increase in the further direction of a flow. Then what you can say that D will be correct. Specific entropy will definitely will be higher for the point F as compared to the point E, right? Coming to the Mach number, what is the Mach number, guys? After normal shock, Mach number, for example, it is greater than 1. Suddenly, after the normal shock, Mach number will be less than 1. Flow will become supersonic to subsonic. So definitely C option is incorrect. What they mentioned, guys, Mach number is here. Based on the option, as we have the memory-based question, so we are not sure about the C option. If it is Mach number at point E is greater than Mach number at a point F, so definitely this should also be correct. Right. What about the other property, guys? What about the other properties? So I'm writing here properties whenever we have the normal shock. After this, whenever the flow is happening like this, remember pressure will increase, stagnation pressure will decrease, velocity will decrease because Mach number will decrease, static temperature will increase, stagnation temperature will remain constant, density will increase, entropy will increase. So these are the this we have discussed in the classes, guys, right? Directly we have given this particular thing, and based on that you can answer A. What about A? A will also be correct. B will also be correct, right? So we are not sure about the options. I think in the C option in the examination they have mentioned Mach number at E, basically what less than Mach number at F, right? So C option would be correct, incorrect in that case. If the option will be like this, whatever we have mentioned here, Mach number at E will be more than Mach number at F, definitely this will also be correct, right? Now, definitely when the velocity will decrease, pressure will increase, density will increase because after the normal shock, the molecules will be getting compressed. Molecules will be getting compressed because in the disturbance zones, molecule will be getting compressed. So density will increase, right? So A, B, C, D, all the options will be correct. But again, I'm saying these are the memory-based question. We are not sure about the options, right? Please make a note of it. Okay, why the temperature will increase? Static temperature will increase. Static temperature will increase because the kinetic energy will be getting converted into enthalpy. Why kinetic energy will be getting converted? Why kinetic energy will decrease? Because there is a large drop in the fluid velocity. Mach number will suddenly reduce to less than 1. Subsonic means velocity will decrease, kinetic energy will decrease. And according to first law of thermodynamics, energy cannot be created, cannot be destroyed. It has to go somewhere, right? And that will go to the enthalpy, and that will rise the temperature. But total enthalpy, stagnation enthalpy will remain same. Remember, H1 plus V1 square over 2, H2 plus V2 square over 2. Here, for this one, we require only one condition. For this steady flow energy equation, we require only one condition. What is the condition? There has to be adiabatic process. We don't need whether the process is to be reversible or irreversible, right? That's why even though it is an irreversible phenomena, but this H naught 1 is equal to H naught 2 is still satisfied in case of normal shock. Suppose this question would have been for the oblique shock, then we cannot certain about the Mach number at the after the shock wave. Whether it is a strong oblique shock or weak oblique shock, based on that we need to answer about the Mach number. But as far as the normal shock is being concerned, definitely Mach number will be less than 1 after the shock. So these are the things that you need to remember, guys, right? Please make a note of it. Again, we are discussing for the ideal flow, no, basically ideal fluid or ideal gas. We can apply the ideal gas equations, right? Coming to the next part, that is the thing. But if you talk about the next question, guys, again you can see this question. This question is again from the, you can say, either machine design or strength of material. That means this is the question from the section B, guys, right? Section 2. A solid massless cylindrical member of 50 mm diameter is rigidly attached at one end and it is subjected to axial force P, and there is a torsion which is being applied, which is of 600 Newton meter at the other end. Assume that the axis of the cylinder is normal to the support. Consider the distortion energy theory with the allowable yield stress as 300 megapascal. The factor of safety in the design will be what? The factor of safety of design will be what, guys? So please try to note down the data. Then we will discuss. We will start discussing this question. So what we can discuss, guys, first of all, here if I take about the data, there is a axial force P which is of 100 kilonewton, and there is a torsion which is being applied T, which is nothing but 600 Newton meter, guys. 600 Newton meter. What they are asking? What is the factor of safety based on the maximum distortion energy theory, guys? Right. So very first of all, we have to consider a critical section. What is the critical section, guys? Here. What about the critical point? If I'll be asking you what is the critical point, what should be the critical point? So if you take any point on the top surface, or bottom surface, that will be critical point, right? If you take a point A here, or maybe you can take any point A, suppose for example, and then if you try to see the what are all the state of stress for a point A, then what you can observe is there will be some if you try to take a point A, and if you take a axis like this is X, this is Y, this is Z. Because of the twisting, there is a distribution will be like this. There is a distribution like this, right? For a point A. So what you can say, guys? If we talk about the point A, there will be tau X Z. For example, this is the tau X Z. What about this? And this is the torsional shear stress because of the twisting moment. And what about because of the P? There is the normal stress sigma XX, which is nothing but P over area. So which is nothing but sigma XX. Sigma XX. So if you talk about the sigma XX, what you can write? 100 into 1000 over pi by 4 d square. What is the diameter, guys? The diameter they have given 50 mm. 50 square. So if you try to note down the values, what you can write? 100 into 1000 into 4 over pi over 2500. So you are going to write 50.9296 megapascal. What about the tau xz? 16t over pi d cube. What is the t value, guys? T value is 600 into 1000, because everything we need to convert in Newton mm so that we can get megapascal. That means 1 megapascal is 1 Newton per mm square. So what you can write here? 16 into 600 into 1000 over pi over 50 cube. So which is nothing but 24.4462 megapascal. Once you got the torsional shear stress, once you got the normal stress, what you can just do, you can write the equivalent stress based on the distortion energy theory, which is also called as what, guys? Hex stress, right? Hex equivalent stress. What is the formula, guys? Here we have the formula like half of sigma x minus sigma y whole square You can also write sigma x, sigma y minus sigma z whole square, plus what you can further write, sigma z minus sigma x whole square, plus 6 tau xy plus tau yz square plus tau zx square. But in the problem, they have not given anything regarding the information whenever the torsion is acting, twisting moment is acting. And when because of that, if you take a point at that particular point, other tau xy, tau yz will be 0. So tau xy will be 0, tau yz will be 0. Again, we have sigma y that is 0, sigma z is also 0, sigma y is also 0, sigma z is 0. So if you try to write sigma equivalent, which is equal to sigma yt over factors of t, according to maximum distortion energy theory, guys, right? So what you can write further? Sigma x square plus 3 tau xy square, which is equal to sigma yt over factors of t. For material to be safe, this sigma equivalent should be equal to what? Or less than equal to what? Sigma yt over factors of t, right? So further, what we can write? Sigma x square. What is the sigma x? 50.9296. 50.9296 whole square plus 3 tau xy square, which is nothing but not here tau xy. Here we have tau xz. What is the tau xz? 24.4462. 24.4462 square, which is equal to what is the sigma yt? 300 over factors of t. So from here, if you try to calculate 50, let's say 24.4462 into 3 plus 50.9296 square, take under root of that. So when you try to calculate, you are going to get factor of safety, which is equal to 4.53. If they are asking round up to 2 decimal places, so that should be the answer. That should be the answer for factor of safety. Don't try to find it out the sigma 1 and 2 principal stress. Again, from that also you can get the answer, right? But don't try to make your calculation a little bit lengthy, right? Again, moving on to the next question, again from the strength of material. A horizontal beam of length, what we have, the length is 1200 mm, is pinned at the left end and the resting on a roller onto the right hand. A linearly varying load, uniformly varying load, as given in the figure, the magnitude of the maximum bending moment applied on the beam. Please note down. Magnitude of the maximum bending moment they are asking, guys. Again, there is a two method to solve this particular problem. There are two particular methods to solve this particular problem. One is either you remember directly the formula or you try to go with the procedures, right? Here, if I go with the procedure, like if I say here, there is a RA, there is a RB. Again, there is a horizontal reaction, but that will be zero because there is a no horizontal force, external force. Here, what we have, we have a length and W naught. So everything I'm considering in the form of W naught into L, right? So where W naught, we know that it's 100 Newton per meter and L is what? 1200 mm. All right, guys, 1200 mm. So try to consider here the next part. First of all, we need to find the reaction forces. First of all, we need to find the reaction forces. What are all the reaction forces, guys? Summation of forces in the y direction to be 0, which is obviously RA plus RB, which is equal to half of W naught into L. W naught into L by 2. Right. And if you take summation of moment about A point to be 0, again, this is a very lengthy method, guys. Whatever the method I'm explaining right now, that seems to be lengthy method, but you have to follow if you don't know the formula directly. Summation of moment about A point to be 0, if you write, then what you can write, guys? Here you can write RB into L, that is acting in the anti-clockwise direction, which is equal to clockwise movement, half of W naught into L, and that will be acting this W naught into L over 2. This will be acting at a distance 2 by 3 of L, 2 by 3 of L. So you are going to get W naught into L over 3. This is the value, my dear friend, for RB. What about the RA value? RA value is W naught into L over 6. W naught L over 6. Please try to calculate it. That is the value you are getting for RA. Once you get the values of RA and once you get the values of RB, what you can do directly, you can get the what guys? You can take any section, you take any section and you try to calculate what is the shear force at that section at a distance x. Shear force at that particular distance we need to equate to 0 because shear force and bending moment relation is what? This is the relation. For maximum bending moment, dm by dx to be 0. For that shear force to be 0. For a maximum bending moment, the shear force need to be 0 so that the slope of the bending moment is what? Slope of the bending moment diagram is what? 0 at that particular point. Now, if you try to calculate shear force at that location to be 0, you can write here W naught into L over 6 into X minus. At this location, what is the value of load, guys? The load you can write here. What is the load? W naught into X over L, right? So W naught into X over L, half of that into X, and we are finding the shear force, right? So that is the value of shear force. That is the value of load that will give the shear force. Now here, no need to multiply with the what guys? X, because we are writing what? Shear force, not bending moment. That we need to equate to 0. So if you try to equate to 0, what you are going to get? W naught into X square over 2L. So finally you are going to get what guys? L over root 3. At this particular location, your bending moment is what? Maximum. Your bending moment is maximum, guys. Can you please calculate the location? At that location, what is the maximum bending moment? Try to put the value. L is what? 1.2 over root 3. If you try to calculate, you are going to get 0.693 meter. At that location, try to calculate the bending moment. First of all, W naught into L over 6 into X minus W naught into X by L, half of that into X. What is the bending moment because of this portion with respect to X? It is X by 3. It will be X by 3, guys, into X by 3. Now try to put W naught is what? 100. L is what? 1.2 over 6. It is 0.693 minus W naught into X square. So W is what? 100. X cube 0.693 cube over 2 over 6L over 6L. So here I'm writing what? 6 into L. If you try to calculate what the value you are going to get, guys, 100 into 1.2 into 0.693 over 6. So 13.86 minus 100 into 0.693 whole cube over 6 over 1.2. So you are going to get like 4.6224. So finally, what is the bending moment? That is the maximum bending moment at that location. Like 13.86 minus of these, you are going to get 9.237. 9.237 Newton meter. Either you can follow this one or you have to directly remember the formula. What is the maximum bending moment? For a standard cases, W naught L square over 9 root 3. If you put the values directly, you will get the answer. Put the value. W naught is 100. L is what? 1.2 whole square over 9 over root 3. You are going to get 9.237. Just like you remember the case for a simply supported beam for a uniformly distributed load. W naught L square over 8. That is the maximum bending moment. Like that, you try to remember. Like that, you try to remember this standard case results. Now, what is the benefit? Two benefits are there. You can reduce the times by calculation of this particular one-page solutions. But if you are not having any confidence on remembering the formulas, you have to go through the procedures. Again, moving on to the next question, guys, here. Again, the next question is from the engineering mechanics. Here you can see that the question from the engineering mechanics. This question already being taken from the what? If you see the previous year question of civil engineering, like 2020 or 2021 paper, very similar question they ask. They have taken the references and again they have framed the question. Just little bit of changes of the data, guys. Only fundamental concept involved in this question is that if you try to separate the joint at B, what they are asking, a 3-hinge arc, 1, 2, 3. At ABC, there is a 3-inch in the form of a semicircle as shown in the figure. The arc is in under what? It is under the static equilibrium under the vertical load of P, which is 10 kilonewton. And here, little bit of correction on the data here. It is 100 kilonewton, and the Q is what? 50 kilonewton. Neglecting the friction at all the hinges, magnitude of the horizontal reaction at B. This particular fundamental concept is already given in the Gere-Goodnow solved example. And if you are not following the textbook, again, if you follow the previous year question in the civil other branch, if you solve, already one question is being asked on this concept. The concept is whenever you are separating the two joints, this is the arc, left side arc. When you separate from the right side arc, always whenever you are separating, there is a two reaction forces in the two directions, like in the horizontal directions and in the vertical directions. And what is the point here? Let's say By and let's say Bx. And you know that here we have the reaction forces like A, Y, Ax. A, Y, Ax. And what is the load here? 100 kilonewton. From here to here, we have the 3 meter. Now, what you can do to calculate, first of all, we can take the summation of moment about A point to be 0. Then what you can add, guys? 100 into 3 clockwise. This is the clockwise. What about the anti-clockwise? Bx into what? 6 plus By into what? 6. So what are the Bx plus By? Bx plus By you are going to get like 100 into 3 over 6, which is obviously 50. That is the one equation. That is the first equation. What about the second equation? The second equation you can frame it from the second part, half part of this particular frame. Here we have a Cy, Cx, Bx and By. But the load is acting like a 50 kilonewton. So what you can take summation of moment about C point to be 0. This is the C point. So By into 6, anti-clockwise movement, 50 into what? 3. 50 into what? 3 anti-clockwise movement. That should be equal to what? Bx into 6 clockwise movement. Anti-clockwise movement should be equal to what? Clockwise movement. So what you can get, guys? By plus 25, that is equal to Bx. What you can do, you can put the values to get the Bx value. What you can do, you can put By. This is the second equation. Solve first and second equation. What you can do? Bx plus By. What is the By? Bx minus 25, that is equal to 50. So 2bx is what? 75. So bx is what? 37.5 kilonewton. That is what the answer for this question. What about the by? By will be 12.5. So what should be the right answer? 37.5, which is obviously corrected up to 1 decimal places. Right? Again, that's why we used to say in the class, try to solve PYQ of other branch. If you are not following that mantra, you can follow, try to solve the textbook solution, textbook problem. If you follow both the things, definitely no question will look new question to you in GATE exam. Moving on to the next question again from the engineering mechanics here. Try to note down the data, then we will discuss. A RAM, you can see that in the form of what they have given. There is a RAM which is being given in the form of a rotating body which is having a certain size of L 9 meter and the length of what guys? And there is a length of 9 meter and width is what? 2 meter. It is suspended. It is suspended by what? It is suspended by the two parallel ropes of length 7 meter. Assuming the center of body is at its geometric center only, there is no eccentricity is being involved. G is what? 9.81 meter per second square. Uh, for striking the object, for striking the object P with the horizontal velocity 5 meter per second, what should be the angle theta from the vertical, which from which the ram should be released from the rest? You know that when it is fixed, when it is fixed, what will happen, guys? The moment your ram is being, released, definitely it will be what? It will be somewhere here. This is the initial position. Will be the final positions, and your string will be like this. So what is the difference from here to here, guys? The difference is h. That means initially you have taken the body up to some up to what we have taken the body, guys. Your body is being tilted by the angle theta. That means there is some potential energy is there in the ram. Once you are releasing it, and the moment it is striking with the P object, definitely it is what? The string will become vertical. All the potential energy would have been converted to what? Kinetic energy, just like a pendulum. Here we have highest potential energy, and then at this particular point, it is going to have what? Maximum kinetic energy, right? So that is what the conservation of energy that you need to use it, guys. So what is the conservation of energy, guys? The potential energy that should be equal to kinetic energy, mgh. Initially, with this much of height, we have taken this body, this ram, and then we are converting into what? Half of mv square. So from here, what is the h? V square over 2g. So try to calculate v. It's a 5 square to 9.81. So if you try to calculate a value, you are going to get the value like 1.274 meter. Once you get this value, now it's a very school mathematics, guys. See here, you have this particular value. This triangle you have theta. This is 7 meter. String length cannot change, right? And then from here to here it is 7 meter. But here to here there is a h. Then what about this? 7 minus h. So what about this theta, guys? Can you calculate this, the value of theta? 7 minus 1.274. So what you can write here? Cos theta will be 7 minus h over 7. So 7 minus h is what? 1.274. 7 minus 1.274 over 7. Cos inverse of that. If you do that, you will be getting what? Theta will be 35.115 degree. This will be the value. If you see the option 35.1, they have given us answer. One of the option they have given 35.11. But no need to confuse by the diagram. That is a very simple trick. You can take any object with your hand and just take a pin with the inclined angle. And top of the pin, you try to fix it and then try to move your hand. Definitely your hand should be moved to the what? Downward side. Because string is what? String is at an angle fixed. String cannot bend. It cannot deform. Right? So what will happen, guys? The translation, during the translation motion, definitely the object will be coming down. That is from the higher height, it is coming to the what? Lower height. Then what we can expect? The potential energy has to be converted into kinetic energy. If you are not able to visualize, you cannot answer any question in the GATE exam. Right? Every question will not be like a easy question that will be served on the plate. In fact, they have given the hint also by taking the object P at a lower height. You can see that. So that is all about this question. Moving on to the next question, guys. Again, this question is from the vibration. That question at the first instant is not at all easy. So I'm keeping this into the category of what? Tougher. Why? Question is not that tough, but I'm putting in the tougher side because in the tough category because at the first instant, whenever you see this particular problem, you cannot answer easily. That means you will not be getting the idea like how to start this question. Because of that only, I am keeping this, this particular question onto the tough side. A vibratory system consists of a mass m, a vertical spring, mass m, vertical spring of stiffness 2a, and horizontal spring of stiffness k. The end A of the horizontal spring is given a horizontal motion x is equal to a sine omega t. The other end of the spring is connected to inextensible rho that passes over the two massless pulley as shown in the figure. Assuming the mass is equal to 10 kg, k is 1.5 kilonewton per meter, neglecting the friction, magnitude of the critical driving frequency for which the oscillation of the mass will become excessively large. You know, in the forced vibration, we call one term called resonance. Because of the resonance, what happened at the point of resonance, excitation frequency or forced frequency will become equal to what? Natural frequency. The moment it becomes the natural frequency, the system will be start vibrating at a higher amplitude, and that is what they are asking. So you what they are asking omega, which is obviously equal to what? Omega n. So first of all, we need to find what is the natural frequency. That will become automatically answer for this question, guys. So here what you can see, if I draw the diagram here. So here I'm assuming that there is an end A. Again, I'm considering this end A to be as a fixed site. We will try to submit the solution, whatever the solution I'm giving right now, that is I'm giving the solution based on the energy method, right? By considering this problem of forced vibrations, I will be giving the solution that is a very lengthy solution also. So that you will be getting actual problem what they have been asked in this one, right? But as of now, once the response sheet will be out, along with the other questions, we will try to discuss in detail solution of this particular problem, right? So there is a spring, and again there is a with the spring there is a pulley with the string. Moment you are going to get the idea. After that, it is on the moderate side. Because you are not able to start in the examination, definitely you cannot treat this particular problem on the easier or moderate side. Definitely, it is one of the good problem. So here you can see there is a block of capital M, and then we have the spring which is being connected. 2kk. Fine. So these are the things they have given, guys, right? Mass is given as 10 kg. Stiffness is given as 1.5 kilonewton per meter. What else they have given? Okay. So here, if you try to observe, guys, there are two method. One is the DLM method. Second is energy method. One is the DLM method. Second is what? Energy method. According to me, if you ask me, DLM method you may find little difficult because of the tension in the rope. Otherwise, you can solve by that method also. But by the energy method, it is one of the easiest method by means of which you can get the equation of a motion. Just observe. Suppose mass is getting displaced by the amount x. Definitely, this spring will also be getting displaced by the amount x. What about this spring? Let's say there is a tension here. If this is the mass which is getting displaced, so this pulley will also be getting displaced by the amount x. Then what happened here? Let's say here we have the tension T. It will be what? T by 2, T by 2. And if you analyze how much of pulley is getting displaced, this pulley and this spring, how much of it is getting displaced? So definitely the sum of the work done of a string is actually what? Zero. Because whatever the work done is done by the string is what? Almost like a zero. So here what we can tell, guys, from here, let's say this pulley is getting displaced by the amount x. On this pulley, how much of tension? The tension is what? Capital T. The tension is capital T. X, this is the displacement with the capital T. How much of displacement of this particular pulley? Let's say the displacement is, for example, y. And how much of tension is there? T by 2. Right? Definitely, we don't know the directions. So I'm keeping it as minus sign. That is equal to 0. So what is the y? Y will be equal to 2x. So definitely what you can say, guys, this spring will be getting displaced by the amount 2x. If this mass is getting displaced by the amount x, this particular upper spring, horizontal spring will be getting displaced by the amount 2x. Now simply what you can simply follow the kinetic energy. First of all, find the total energy, which is equal to kinetic energy plus potential energy. What is the total energy? Kinetic energy, half of m v square, which is nothing but x dot square. And what is the potential energy? Obviously, potential energy will be offered by the spring force. What is the potential energy, guys? Half of k. This is a 2k. And what is the displacement? X square plus half of horizontal spring. What is the potential energy? K. And what is the displacement? 2x square. So what is the total energy? You can write here half of capital M x dot square plus what you can write here. It's a kx square plus 2kx square, which is obviously what you can write half of m x dot square plus 3kx square. Finally, energy method. What is the method, guys? D by dt of total energy has to be equal to 0 because there is a no damper. If there is a no damper, total energy will remain constant. And if you try to differentiate with respect to time, it has to be 0. So half of m 2x dot x double dot 3x 2x 3k into 2x x dot equal to 0. So m x double dot plus x dot I'm taking common and that is equal to 0. So what we get right here? Mx double dot plus 6k of x equal to 0. If you compare this equation with the standard equation of simple harmonic motion, x double dot plus omega n square into x equal to 0. So what is the omega n? Under root of 6k by m, capital M. So what is the 6 into k? K is what? 1500. What is the m, guys? M is 10. So if you try to calculate omega, which is obviously equal to omega n, 30 radian per second. That is the answer by energy method. If you want to follow the DLMR method, you have to make the free body diagram of this capital M. You are disturbing by the amount x, then what will be the inertia force? Mx double dot will be acting in the upward directions. What about this T? It will be T, for example. What about the spring? The spring will be getting displaced in the downward. It will offer the reaction force in the upward directions. K into what? 2K into X, right? Then finally, what T you can write? T you can write that is equal to what? What is the T you can write, guys? Here you can write here what is the T value? It's a 2 times of tension in the what? It's a 2 times of tension in the what? Other horizontal spring. And other horizontal spring, what you can write further, guys? Other horizontal spring, what you can write further, guys? In the form of stiffness. Tell me, guys, what you can further write? If you take T is equal to T1, if you take T that is equal to T1, then what you can write the horizontal spring stiffness? Here, if you try to note on the free body diagram, it is T, which is obviously that is equal to T. Let's say this is the T, and but you need to write each and everything in the form of X. What you can write, guys, here? That is equal to, let's say this is a tension. I'm calling this tension to be T1. This tension is also equal to T1. So finally, what we can write is T1 plus T1 that is equal to T. So what is the T we can write? 2 times of T1. Yes or no? We can also write T is equal to what? 2 times of T1. Then what is the T1, guys? What is the T1? If you write T1, what is the T1? What is the tension force in this particular string? The tension force is what? Spring force. What is the spring force? K times of 2x. K times of 2x. So further, what is this value? T. T which is equal to 2 times of T1. That can be written as 2 times of K into 2x. And that you can write, my dear friend, the net force in the direction of a motion. The net force in the direction of a motion, which is equal to mx double dot. And that you can write it as minus 2 kx minus 2 4kx, that is equal to what? Mx double dot. Mx double dot plus 6kx, that is equal to 0. So final equation of a motion, either by this one or by this one, you are going to get same. But by the energy method, you are going to get in a very simpler manner. Otherwise, if you want to follow the D'Alembert method, you need to know a little bit more fundamental knowledge about this one. Is free body diagram should be clear. Otherwise, if you just make the wrong free body diagram, you cannot get the answer by D'Alembert method. D'Alembert method, guys. Right? So that is all about these solutions. Moving on to the next question. Here you see the question again from the machine design here. Question from the machine design. Which of the following failure theories is the most conservative against the fatigue failure? So for explaining this one, again from the this question is taken again two copy from 2015 mechanical question. So again, from this paper you can learn two things. One is the PYQ is a must. PYQ of home branch is a must. PYQ of other branch solution is a must. You have to solve each and every problem. Then textbook solution, right? You have to do. That is a mandatory thing for getting the basically during the preparation of GATE exam. Apart from it, you have to practice new question. But these are the mandatory things, right? These are the necessary, but not at all sufficient. What is the sufficient thing? Along with the necessary thing, you have to practice a new questions, right? So if you just plot the graph between the variable stress versus mean stress. So here we have the variable stress S versus S variable stress versus mean stress. So what you can write here? There is a yield strength, endurance strength, ultimate strength. And if you try to connect this with the And if you try to connect this with the this line, and if you further try to connect one more line like SE versus SUT, SE versus SUT. And what is the Gerber line here? We have the Gerber line like connecting from here to here. SE to SUT, and there is a one more line. Okay, I'm not explaining here in this one. Among all, let's say these are the failure points. Let's say we have the failure points. Let me take the failure point for you. These are the failure points, for example. Failure points. After designing, suppose you are getting the variable stress and the mean stress outside this yellow color. Out of all the failure theory, which is the farthest away from the failure point? This line, Soderbergh line. This is what we have the Gerber line. And this is what the green color, what you're observing is nothing but a Goodman line. What is the modified Goodman line? The modified Goodman line is nothing but uh, the intersection of line which is taken from the yield line. This is the yield line. We also call Langer line. This line with the what guys? This particular line with the Goodman line. What is the Goodman line? Whatever the Goodman line, the green color one and this blue color one, what I'm marking here, I'm marking like this. Let's say I'm marking with the black color here. Whatever the black color I'm marking here, that is nothing but modified Goodman line. Modified Goodman line. Modified Goodman line, you can see among all the graphs, the Soderbergh line is a what guys? Is very very farthest away from the failure points. That means it is one of the safest design. No, safest theory for fluctuating load or conservative theory for fatigue load. Then what should be the correct answer, guys? The correct answer must be Soderbergh. You must be having the confusion between yield line as well as a Soderbergh line. The correct answer must be Soderbergh line, right? Again, in next year gate, for example, they are asking which of the following theories of failures are most accurate theory. Most accurate theory, right? So you can plot one more graph over here. That graph is connecting between SE and SYT. Parabolic graph. That is a elliptical graph. This is nothing but ASME elliptic theories. Now, what is the specialty about this one? What is the specialty about this particular line? You have to remember this theories of failure, ASME elliptic theory is nothing but it is one of the most close to actual experimental results. If suppose in next year they are asking which of the following theories of failure, one of the options, suppose ASME ellipse is also given. And they will be asking like which of the following theories of failures are most accurate theories of failure. So this ASME elliptic theory, most accurate theory. Soderbergh is also one of the good theories for ductile material. Goodman is a good theory for brittle material. So these are the points, you must be aware, but The new point, what you are observing is that ASME ellipse is a most accurate theory. Right. Please make a note of it. Moving on to the next question. Again, this question is from the strength of material. Again, this question is from the what we have from the strength of material. And if you look at this question, guys, the figure show a thin cylindrical pressure vessel constructed by the welding plates together along the line that makes alpha is equal to what? 60 degree with the horizontal. Now this vessel is what? A closed vessel with the hemispherical ends like this, right? Which is having a wall thickness of 10 mm and the diameter is what? 2 meter. When the cylinder is subjected to internal pressure of 200 kilopascal, what is the magnitude of the normal stress acting on the what? On this weld, acting on the weld of the vessel. The normal stress which is acting on the weld of this vessel, guys. So here, before proceeding these questions, let me just make the diagram. For example, this is the weld. This weld is inclined at an angle what? 60 degree. But always we take the angle from the vertical. Then what is the theta value? It should be 30 degree plus anti-clockwise directions. Now we are calculating sigma and theta exactly on 30 degree. So what we can write sigma x plus sigma y over 2, sigma x minus sigma y over 2 cos 2 theta plus tau xy sin 2 theta. But before that, we need to find what is the sigma x, obviously longitudinal stress. What is the sigma y? Hoop stress. That you can calculate very easily. PD over 2T, PD over 4T. P is what? 0.2 megapascal. Because see, what is the pressure value? It's a 200 kilopascal. You convert everything in megapascal, you are going to get 0.2 megapascal. The diameter is given as 2 meter. That you can keep it like 2000 mm. OT. What is the T value? T value will be 10 mm. So if you try to calculate it, guys, 0.2 into 2000 over 4 over 10, you are going to get 10 megapascal. What is the value of hoop stress? Again, it is 20 megapascal. What is the tau xy? There is a no shear stress. There is a no shear stress, right? So if you try to put the value 10 plus 20 over 2, sigma x is what? 10 minus 20 over 2 cos 60 degree because 30 into 2 will be 60. So again, if you try to calculate, that will be 12.5 megapascal. That should be the correct answer. Again, what is the source of this question? The source of this question is Gere Goodne, unsolved example. Unsolved example, and one question is given in the solved example. So what you have learned from this session, guys? One thing you learned that you have to solve previous year question of other branch, previous year question of your own branch, textbook practice, and regularly you have to attend the classes. That is a whole and sole thing about the GATE exam. If you miss any of these four elements, and without this, if you're going to examination hall, that means you are going on your own risk. Coming to the no, these are the total you know section what we have discussed. Upcoming, you have the section 4, that is nothing but manufacturing and industrial engineering, guys, right?
Yeah, yeah. So thank you, Rahul sir. So we'll have in between Naveen sir. We can start with math FT or section 4. What
We'll
is it?
start with math and apti and then we'll go for section 4.
Yeah, yeah. Actually, Rahul sir, it was planned like paper analysis, math, then your session, and it was for the section 4. But anyway,
Okay.
no issue. So let's Naveen sir start with math and FT. I'll make you presenter.
Is the screen visible?
it's visible.
Okay, let's start. Okay, good evening, guys. So, continuing with the previous session, like from section 2 and 3, now we'll go to section 1, that is general aptitude and engineering mathematics. Coming to the questions, we have some memory-based questions here, which are in math and aptitude as well. The first question is from the aptitude, or we cannot differentiate properly from math and aptitude, but by seeing the question, we can say this is from aptitude because this is a very generic question, and it's very simple to answer this question. And you can see this ratio, that's been given here, and they're asking, given the denominators are non-zero, obviously, if your denominator is zero, then the value doesn't exist. So the value of px plus qy plus rz is okay. So here itself, we can say that, like, let us assume that we can, take this as equal to some constant a. Okay. So from here, we can write the equation as the first one, like, we take this 2, and then you can write this as x is equal to a into pq minus r square. Then you take this 2, right? Then that is y is equal to a into qr minus p square, and then you take this 2, that is z is equal to a into rp minus q square, right? So if you want to find out this, then what you have to do, you have to add this up. So that is p into x, that is p into a into pq minus r square, right? Plus q, that is q into y, that is a into qr minus p square, right? Plus r into a into rp minus q square. So if you open up, then a will be a common value. So remove the a aside. Then you open it up. This will be p square q minus pr square plus q square r minus qp square plus r square p minus rq square. If you say this rq square, this and this values are same, these are cancelled, right? And rp square, this is cancelled, this and this is cancelled, hence the value is 0. Hence the answer for this question is 0. It's a very simple question, straightforward, without any fuss and all. You can easily solve within below 30 seconds. You'll be able to solve this, right? And the second question is, 4 equilateral triangles are used to form a regular closed three-dimensional object by joining the edges. The angle between any two faces is. It's a kid's question. It's a simple question. The kid can answer this who has some basic geometric, understanding. So 4 equilateral triangles. So it's kind of something like this. Sorry. Okay, let me try it again. Wait, my pen is going in a different direction. Let me put a point and then I'll write. Okay. So this is somehow, I'm drawing it in a very bad way, but yeah. So they're asking angle between any two faces. So this is phase 1 and this is phase 2. So if you see the angle between that, all are forming a equilateral triangle. What is equilateral triangle? The angle between two edges in a triangle is 60 degrees. So the faces here will be angle between any face, two faces will be equal to theta is equal to 60 degrees. So if they're asking in degrees, you have to put 60 degrees. If they're asking in radians, it's pi by 3 radians. That's it. Okay. And the third question is, how many combinations of null sets of B and C are possible from a set A 2, 3, 5? Satisfying the condition A is a subset of B. A is a subset of B and B is a subset of C. Okay. So A is a subset of B. So this, what is given, should be a subset of some set B. And again, this B is a subset of some set C. So this is a little bit of ambiguous here. But because we do not know what are the number of values in B, right? And I mean, of course, again, this is a memory-based question. Maybe the question will be entirely different. Once the real question paper has come, then only we'll be able to see what is the correct question, and then we'll be able to solve the question. But based on the memory question, the question seems to be very ambiguous, because how do you find out the number of, the non, uh, you know, null sets for B and C without knowing the elements in B? B can be anything. B can be more than A, more or equal to A, right? We do not know anything about that, right? So that is where the question seems to be very ambiguous. So hence it's a question mark that, and there won't be any solution for this. But if you want to find out, then let's say if A is there, A is 2, 3, 5, right? Then if you want to find out the number of subsets, it will be simply 2 power 3. Right? In that, what will be 2 power 3? 8. So these are total number of sets. And if you want a null set, what is null set? Null set is this thing. This is subtract -1, then you'll get 7. So 7 will be the null set if you know the values of elements in the set. But B can be anything. We do not know. And C also can be anything, right? So there is no end for this. If B can be more than A, like B can be of 10 elements, right? Because that is the issue that the question is posing here. So I assume that the question is having some ambiguity. If this is the question, then obviously we can raise to the committee that, of course, when once they'll give you some time for you to raise the questions, right? So we can raise it. Or else, if the question is something else, then we'll be able to solve the question. Okay. So let's skip this for now. Once we get the full, gate question paper, then we'll be able to answer this properly. Okay, let's proceed. And again, a simple, kids question. Find the odd number, odd one out of the set, right? So what is the odd here? So 11, 17, 19, 21, 23, 29, 31, 37. See, you see 11 is a prime number, 17 is a prime number, 19 is a prime number, 21 is not a prime number, 23 is a prime number, 29 is a prime number, 31, 37 are prime number. This is non-prime number. All are prime numbers. So this is the answer. This is a simple question again, non-prime number. Okay, so let's proceed. And that's where we end our aptitude. And this is what is from the mathematics. Of course, we have to solve this question, and this is what is your mathematics, right? So what is the question? They have this double integral with the variables of x and y. They're asking if this integral whatever they've given is equal to this value, then what is the value of a here? It's a very simple question again. So you keep one constant and solve the integral for other, and then you solve the integral of the rest of things. As given here, we'll integrate y for the variable y first, and then we'll integrate the variable x. Okay, so let's take this, and maybe I will integrate this first. Okay, 1 minute. I think there is an issue with my pen. Let me. One minute. Okay, fine. So let me take this. Right. So let me solve let me integrate that first. Okay. So what is that? For this, we are integrating with the variable y. So x will be the constant value here. So assume that x is the value that is constant. So let me write that. So it will be x is equal to 3 to 4, right? Integral. So integrate. So I will send the dx outside, dy will be inside, right? 1 by x plus y whole square, right? So if you are integrating with x being constant, it is 1 by x minus x plus y, or you can say some constant value plus variable whole square, right? So if you do, it's like this, like it's by some constant plus some y whole square. So this I can write as c plus y minus 2. So if you're integrating this, this will be c plus y to the power of 2 plus 1 by minus 2 plus 1. So this will be c plus y minus to the power of minus 1 minus 1. So it will be minus what is that, 1 by x plus y. That's it. This is the integration for the limits of, what is the integration limits, y is equal to 1 to y is equal to 2. That are the limits that they have given, right? So let's solve this. So if you take this, then you substitute 2 first. So it is minus 1 by x plus 2 minus of my 1 minus 1 by x plus 1. So this is what is the internal value, and we have a dx, and again we have a integration that is with respect to x. So this is from 3 to x is equal to 4. So solve for this. This is, you can write this as plus, so x minus x plus 1, right? Okay, we'll do one thing. Instead of solving it, we can even, I think we'll do it. So x plus 1, so minus x minus 1 plus x plus 2, something like this, right? 1 minute. There is some misunderstanding here. I think no. 1 minute. Okay, we'll do one thing. Instead of solving this fuss, we will do here itself, right? So what we'll do, we'll integrate this separately. So this is 1 by x plus 2. So integration of 1 by x plus 2 or is ln x plus 2, right? So this will be minus ln x plus 2 integration of this, and plus ln x plus 1, right? So this is the integration. So the integration or limits are from x is equal to 3 to x is equal to 4. Let's substitute this and find out the values. That's it. So if you're doing it, what is that? We have, this is 4. So if you're okay here, we can do one thing. This is, we can use the properties of logarithm. This we can write as minus ln x plus 2 plus ln x plus 1 as, we can send this set. So it is ln x plus 1 by x plus 2, right? So this will be, okay, 1 minute. Again, there is an issue with pen. So this will be ln x plus 2 by, sorry, x plus 1 by x plus 2. X plus 1 by x plus 2. And the integral limits are from 3 to 4, right? Isn't it? 3 to 4. So directly we can substitute this and find out the answer. That's it. So we can substitute. So this will be ln, first you substitute the value of 4. 4 plus 1 is 5, right? Divided by 6 minus ln of, this is 3 plus 1, 4 by 5, right? If you can substitute, when we have this thing, again, we can go back and use the properties of logarithm. If you have this, we can write this as ln. You know what is ln a minus b? It is ln a by b. Ln a minus ln b is ln a by b. So we can write like this. So this is 5 by 6 by 4 by 5. So if you do this thing, this will be ln 5 into 5 is 25 divided by 6. 6 4 is 24. So this is ln 25 by 24. And what they said, this value is e to the power, log e to the power of a by 24. So the value will be ln e to the power of log e to the power of, there is some mistake, isn't it? There's no mistake, right? Okay, This is not E.
That is ln of a by 24. Yeah,
I think it is the
it is
base.
base
Base, yeah.
ln of e. Yeah.
Yeah, it is
So a is
ln.
24.
Yeah, so A by 24, right? So that is E. So this is A is equal to 25. That's it. So this is the answer. Okay. Okay, let's proceed. So again, there is a question from mathematics, and this is from the probability and statistics. And it's a very simple question again. So I feel like the questions are a pretty bit easier on the mathematics side. I'm not talking about the complete paper because we cannot comment on the complete paper as well. But here I can see the questions are very straightforward. If you have solved previous year questions or some practice questions that you have already answered in your classes, it will be very easy for you to solve this question. Okay, it's a simple question. So let x be a continuous variable, random variable defined from 0 to 1. It's a uniform distribution, what they're talking about, such that the probability density function is 1 for x 0 is then x less than or equal to 1. Something, if it is otherwise, then it is 0. Then y is given as log, again this is the base, x plus 1. Then the expected value of y is. That's it. It's a very simple question. So they're asking what is the expected value of y. So what is the formula for expected value of y? It is minus infinity to plus infinity, right? Y into the function. What is that function? The probability density function dx. That's it, right? So now what is f of x here? F of x is this, but we are integrating from minus infinity to infinity. So here, if we can say that the integration is valid only in this range. So I can convert this as expectation of y is equal to 0 to 1 because the other rest are zeros, we know that. And what is the value of y? Y is log x plus 1, right? And what is the value of f of x? That is 1 here. So directly substitute into 1 dx. A simple question again, just try to integrate this, you'll get the value of expected value of y. So let's integrate that. So expected value of y is equal to, what is this? Log x ln. I mean, you can even write ln also. It's like they're saying log, but as it is a natural base, we can write ln, no problem. Natural logarithm. So let me replace it with ln, right? So now we have this x plus 1. So x plus 1 we can treat as some variable, some t or k or something like that, right? So let x plus 1 is equal to some p. So differentiate on both sides, we get dx is equal to dp, right? So let's substitute back in this equation. So instead of x plus 1, we can substitute as p. Instead of dx, we can substitute as dp, right? So let's do the substitution. So integral, what is that? ln p dp. And what is integral of this? The integral of ln is, anyone? ln p dp. Anyone who is, okay, no one is there. So fine. So it will be some 1 into, so t, so p into integral ln p. So we can use that Eilert rule, ln p, right? Minus p, right? So this is from some integrals. If you want to convert the integral, here we have x varies from 0 to 1. So here we can say the p varies from x plus 1, right? So it is 0 plus 1, 1 to 2, 1 to 2. So we can write that as 1 to 2, 1 to 2. So we can write that is substituted. So 2 ln 2 minus 2. This will be minus 1 into ln 1 minus 1. This is dot. Okay. So if you do the calculation, you will get the answer as 0.38 some 6. Okay. So that is the value of this question. It's a very simple question again. Simple basic mathematics. People will be able to easily solve this question and go ahead. Okay. That's it. Next is core subject. Already Rahul sir has discussed the different parts of fluid mechanics, strength of materials, machine design as well. So I'm going to discuss the section 4. So please note that from now we are going to discuss the solutions of section 4. Again, section 4, as Rahul sir said, it's a little bit lengthier, but the questions are very, very easy according to the memory-based questions that I got here. Maybe there are some questions which are tougher. I don't know, but whatever the questions I received here are very easy. One or two questions are a little lengthier, but yeah, we can easily solve that if you have practiced the gate questions, previous year gate questions properly. We will be able to easily solve these questions. Okay. So in a workstation with a single server, the job arrives at 5 jobs per hour. So we can say that the arrival rate will follow the Poisson distribution, that is lambda is equal to 5 jobs per hour, right? And the service rate, that is an exponential distribution. We assume that it's an exponential distribution. It is 6 per minute. 6 minutes per job. It means that in a here we are given per hour. Here we are telling about 6. So if you are taking 6 minutes per job, in 1 hour, how many jobs will be completed? It is 60 by 6. That is 60 by 6 per hour. That I can write as 10 per hour. It means 5 are coming, 10 are leaving, right? Now, what is the probability that system is idle? So this we have already discussed in our class as well. The probability that system is idle is denoted by P naught or P0. Probability that the system is idle is P0. And we have the formula for that. We have even derived in our class, that is 1 minus rho. Rho is given as lambda by mu, right? There are so many names for this tunnel ratio, that's ratio. There are so many names, but it is lambda by mu. So lambda by mu is 5 by 10, and this will be 1 by 2, that is 0.5. So obviously, if you're giving substituting this value, this is 1 minus 0.5. So hence, the probability that system is idle is 0.5. Half the time, the system is idle. That is probability again. Please remember, this is not a deterministic value. It's a probabilistic value. Half of the time, probably the system, the workstation is idle. That's it. Okay. So very simple question, straightforward. Whenever we solve this, whenever we are discussing the queuing model, the first question we are going to solve is this only. So if we have, whoever has attended our classes will be able to solve this question within 30 seconds. Under 30 seconds, people will be able to solve it. Okay. And next is question number 17. That is the optimal solution for meeting the total demand. Okay, this is question from transportation, but here there is a catch. If you go for a long way and solve this question, like what is the, or there are so many ways that you can solve this problem in transportation. First, you have to find out the initial feasible solution, in the sense like you can use your northwest corner rule, least cost method, or maybe Vogel's approximation method. There are so many methods through which you can solve and find out the initial feasible solution, or a feasible solution, or basic feasible solution, you can say. And then you use your optimality procedures such as Modi method, and or maybe you can use your stepping stone method to solve for the optimality. But that takes a very wrong route. So instead of that, if you see the question properly, you see the supply and demand. I think so. This is supply. Maybe that is demand. Not sure. Maybe it is the reverse. Maybe whatever it is the case. If you see that the supply and the demand for each point are same, right? So what I can do, I can directly send this 300 to here, right? Or sorry, supply to demand, right? Maybe I can directly send this to here, or maybe I can directly send this to here. So now if you see here, as all the points are same, right? I can treat this problem as the subset of transportation problem, or the simplified version of the transportation problem. What is a subset of transportation problem, or what is a special case of transportation problem? The special case of transportation problem is assignment problem. Right? So what is assignment problem? We have a job and we have a machine. Each job has to go to each machine, and there are some rules and assumptions that we make here. So those are valid here. So why, I'll tell you. So if you see each job, or I can say the demand point is some kind of a machine and the supply point is some kind of a uh, job. And also the very good point here is it's a 4x4 matrix. If it was 4x3 or some kind of a different matrix, then the game would have been different, right? So this is where the people should understand, because we discuss one job, one machine. So 4 jobs have to be there and 4 machines have to be there. So now let's try to understand this thing in terms of job and machine. There are 300 jobs and there are some, there are job and machine. So each job, let's say this is job A, B, C, D, and this is machine 1, 2, 3, 4. Each job has to go into one machine. It means that each demand supply, there's no need of any crisscrossing. Directly all the items are same. So 300 jobs can go to machine 1, 300 this can be go into machine 4, something like that. So this we can convert into a assignment problem without any of this 300 and all. And also this is a balanced transportation problem that also has again a subset of your again, which is valid in the assignment problem as well. So let's convert this into an assignment problem and try to solve this optimality through assignment problem and get to the solution, right? And that will be a little, I'm not saying that it will be cutting down your time, but half of the time will be cutting down, because if you're going for a long method of trying to find the feasible solution, then applying, this Modi method and all, it might take a little lengthier. So here I'm trying to solve this by using an assignment problem way. Okay, let me solve that. So here, if you see, let me take the matrix simply instead of doing all these things. So in assignment problem, what do? You first try to find out the initial solution by subtracting the row minimum. You take the row minimum subtraction and the column minimum subtraction, and then you get the matrix out of it, right? So let's do the column minimum subtraction, right? So let's go for the column minimum subtraction. Column minimum subtraction. If you're doing the column minimum subtraction, what is it? So if you are seeing the column 11, 5, 12, 8, the column minimum is 5. So you subtract 11 minus 5 is 6, 5 minus 5 is 0, 12 minus 5 is 7, 8 minus 3 is 3. So like that, you do the subtraction, column minimum subtraction. Let me write the table. 4 cross 4. Right. So if you see, this is 6073, right? 6073. And if you see, this is again your column minimum is 10, so 1602. This is 6045, right? 6045. 10 is your minimum value there, right? Again here 7 is your minimum value. So 19 minus 7 is 12, 0, 10, and 4, right? So this will be 12, 0, 10, 4. And again 13, and this is your again minimum value there. 13 minus 8 is 5, 8 minus 8 0, 11 minus 8 3, 11 minus 9 is 1. 11 minus 1 is 2, right? So let's do this. So I think 1 minute, yeah. So this will be 5, 0, 3. Now, sorry, this is 9 minus 8, 1. Okay. 1. Okay. So now again, we'll do the row minimum subtraction. Row minimum subtraction. If you do the row minimum subtraction, so here 5 is the minimum value. So let's do that. Cross 4 table, you have to draw it. So that's what we're talking about. So then here you have to do it. You have to do it at the end. As I told you, the steps If you find that some question you know, but you feel that it is lengthier, you have to put it at the end of your paper. Okay, that is very important. Right? So 5 minus 6 minus 5 is 1. 6 minus 5 is 1. This is 7. This is 0. Oh, here are all the zeros. 0, 0, 0, 0. This is 3. So it is 4. 4 minus 3 is 1. 7 and 0. And then 2. Because 3 minus 1, 2. 5 minus 1, 4. 4 minus 1, 3. And 1 minus 1 is 0. Now we got the final matrix here. Now we have to do the ticking business, unticking business, and draw the lines such a way that we have to draw the lines in such a way that it will cover all the zeros. We have to draw the minimum number of lines on this matrix such a way that all the zeros are covered. Here it is easy to solve. Here we can see that, like, we can draw a line here, we can draw a line here, but there is a method to solve. How? So as we discussed in the in our class, first what we have to do, we have to tick, and first we have to do some kind of an assignment. What is assignment? So first we have to attend our first row. Did we attend our first row? Yes. In first row, are we having any zero? Then yes, we have a zero. Then allocate it. This is what is the allocation, right? As you allocate this, obviously this we cannot allocate, this we cannot allocate, this we cannot allocate, right? And then you go to the next row, then you allocate possible one. So obviously I can allocate this, and I cannot allocate this, I cannot allocate this. So we have 2 allocations, but we need 4 allocations, right? Because 4 jobs, 4 machines, 4 destinations, 4 supply points. So for that, we have to do the ticking business. What is that? Tick an unassigned row. So unassigned rows are these 2. We are taking this unassigned rows. If your ticked row is having a 0, right? If your ticked row is having a 0, then tick the corresponding column. The ticked row is having 0 here. I'm ticking the corresponding column. Again, for this also, if you're ticking the 0, this is again the same tick that is going to happen. And if the ticked column has an assignment, if the tick, yes, we have an assignment, and then tick the corresponding row, we're ticking it, right? So I repeat the steps: tick an unassigned row first. Then if the ticked row is having a 0, then tick the corresponding column. If the ticked column has an assignment, let's say, then tick the corresponding row. Repeat the steps again and again until unless there is no more ticking possible. Once there is no more ticking is possible, then what you have to do, you have to draw the line to unticked rows and ticked columns. Unticked rows. What is a tick that has been unticked? That is unticked rows and ticked columns. This is the ticked column. So these lines, whatever we are seeing here, okay, let me draw with some other color so that it will be able to easily understand what we're doing here. This is unticked rows and ticked columns, right? So now you see it covered all the zeros with minimum number of lines, and this minimum number of lines will be telling you the minimum possible solutions. But here you can see 0 and 0 are possible solutions, and 2 lines means 2 possible solutions. But we want 4. That is what is our requirement here, right? Each job has to go to each machine. So for that, what we have to do, we have some kind of changing in the matrices. What we do this thing, that is C cost matrix. C is C minus delta if no line passing, right? And C cost matrix is C is the cost value. C is C itself if one line passing, right? And C is equal to C plus delta if 2 lines passing. Right. So now what is delta here? C is your cost value. This is 175, whatever you are seeing, that is the value of C. And what is delta? Delta is the minimum number that no line is passing. Delta, minimum number or minimum number value where no line is passing. So if you see that, what is the minimum value where no line is passing? The minimum value where the no value is passing is 1, right? So 1, 1, 7, 4, 1, 7, 2, 4, 7. These are the where no line is passing, right? So 1 is it. So delta value is 1 here. So let's take delta is equal to 1. So let's update the matrix. the updation of matrices. Again, we have to draw the 4 cross 4. And what do you have to do? You have to subtract when no line is passing. So C1 is delta. So here 1 minus 1 0, 1 minus 1 0, 7 minus 1 6. So 0 0 6. And again where no line is passing, 4 minus 1 3, 1 minus 1 0, 7 minus 1 6. So 3 0 6. 3 0 6. And again 1 2 minus 1, 4 minus 1, 3 minus 1, 1 3 2, right? Now we'll go to the place where one line is passing. Where is one line passing? This, right? So all are zeros. So what do we have to do? We have to keep as it is. So 0 0 0 0 0 0, right? So this is 0 0 0 0 0 0. This is where no line, one line is passing. That is where you have to keep the value as it is. If you have two lines passing, in the sense like you are having your intersection here, then you add the value of this delta, and that is where 0 plus 1 is, right, 1. So this is where you have added the value. Right? Now what you have to do, again you try to allocate things, right? How do you try to allocate things? So you see the first row, obviously you have some number of possibilities. Don't do an allocation. Second row, you need to do an allocation because of wide number of possibilities again. Third row also you have two more possibilities, no allocation. Fourth row, if you see there are only one allocation, so obviously I can do this allocation. Since I did this allocation, I can't do this allocation, I can't do this allocation. Again, you go to row number 1. If you go to row number 1, again 2 possibilities, don't allocate. Row number 2, 3 possibilities, don't allocate. Row number 3, yes, 1 possibility, allocated. As you have allocated this, you cannot allocate this, you cannot allocate this. Again, you go to row 1, yes, only 1 possibility, allocate this. Hence, you have allocated this, you cannot allocate this. Row number 2, you can allocate this. And that is what is your allocations. You can transfer these allocations to your original matrix, and that would be your answer. So if you go back, this is 0, this like here. So what is the answer? So we can highlight this, and then here this is third row, second column. So this will be this, and this is what is this, second row, third column, this, and this is last one. This is this 9. So now what we can do, we can add up all these things. So this is 11 plus 14 plus 7 plus 9. So this is the value. This is the optimal, cost. So what is this? Let us assume all these things. We have assumed all these things as 1 1 1, right? So what we have to do at the end, we are transferring 300, right? We are transferring 300. So we have to do into 300 because we have assumed it to be assignment problem, right? Because in assignment problem we have only one job, one machine. Here we are transferring 300, right? So all are 300. So obviously it will not change. So if you do the calculation, you get approximately rupees 12300. This is the answer. So this is where the lengthier question comes into the picture. So you have to be very wisely choosing when you have to solve the question. Hopefully once you completely attend all the questions, all the 65 questions, then you obviously might have know that like, oh, this will take some time. So you should be able to attempt this after solving all the easier questions and the questions which are easily, which can be answered without any time, right? After that only you have to attempt this. Otherwise you'll waste your time, right? Fine. Next. So answer is this. So again, let's go to the next question. That is, again, this is from inventory, right? Again, the question is very simple, very simple. It's a little calculation intensive, but yet it's very easier question. So basic formula question. If you know the basic formulas, there is no, some kind of twist or something like that. Easier question. You can easily solve by making without making any calculation mistakes. If you make some calculation mistake, that's it, gone. So let's write what is given. D is given, demand. This is demand. This is ordering cost, or this is H. This is holding cost, right? And this is the per month. Everything is given. So Q is some quantity which is equal to 1.2 times quantity of EOQ. Then the percentage of increase in cost. Simple, very simple, right? What they are doing. So for EOQ or maybe some Q star, we have some cost. right? Cost 1. And they're saying at Q, there is some cost 2. So they're asking what is the percentage of increase from cost 1 to cost 2. Simple question, right? So for that, first we have to find out the value of EOQ. What is the value of EOQ? EOQ or Q star, whatever I say, is nothing but is 2D C naught by CC. Simple, no, CC or CH. Let me write CH because I use carrying cost, but holding cost also is the same one. So CH is equal to 2 into 8000 into 300 divided by CH, that is 12 under root. So if you do this calculation, you get approximately 182.5 units, right? So this is your EOQ, that is your Q star. Now what is Q? Q is 1.25 times of Q star, and that is 1.25 into 182.5 units. So that is 228.125 units, something like that. Okay. So now what you have to do, you have to just calculate the different costs. So the cost at EOQ, cost at Q is equal to EOQ, or maybe Q star is, or maybe I can say cost 1, right? So I'll write TC1 is equal to total cost 1 is equal to, you can use the formula, but yeah, I'll use the formula 2D C naught CC or CH. I can write like this. So this is 2 into 8000 into C naught is 300 into CH is 12. That's it. So do the calculation. If you do the calculation, you'll get approximately rupees 26,290.06, something like this. Now again, you have to calculate the cost at Q, right? So if you want to calculate the cost at Q, so the cost at Q is, maybe I can write TC2. You should not use this. You should not use this formula. I repeatedly during our class we have said this should not use this formula. You have to use the mother formula. That is what is your ordering cost plus holding cost. That is number of orders into ordering plus average inventory into holding. That is D by Q into C naught plus Q average inventory Q by 2 into CH, right? So what is demand? 8000, obviously 8000 divided by what is the value of Q? Value of Q is 228.125. So substituted 228.125 into C naught. What is the value of C naught? That is 300, right? 300 plus Q by 2, that is 228.125 divided by 2 into CH, that is I think 12, right? 12, right? So you do the calculation, you'll get the value of answer as rupees 29947.74, right? So what is the percentage? What is it saying? Percentage increase in inventory cost. What percentage increase in inventory cost? Inventory cost is what? The 1 minute, I think. Did I make the calculations right? Hopefully, yes. Yeah, it's right. So the percentage increase in cost. No, 1 minute. I think I made some calculation 26960. Yeah, I think this is 26945. Sorry for this. Two 6945 point some 54 something. Okay, so the increase is how much? So 26. Okay, I'll write TC2 minus TC1 divided by TC1. TC2 minus TC1 divided by TC1 into 100. We do this, that is 26945.54 minus 26290.06. That is what is calculation intensive. You should not make any mistake. Any mistake in calculations, whatever the concept you know, will go in vain. Okay. So into 100. If we do into 100, you get approximately 2.5%. This is what is the answer. Okay. Again, the question is easy, but calculation is important. You should not make any mistake in the values. That's it. And next question is again, okay, this is from casting. It's a very simple question. Again, this question has come from the solidification time, Chorinov's rule. Okay. So the aluminium is casted in a cube-shaped mold having dimensions of 20, 20, 20 mm cube. Another mold of same material is used to cast. These kind of questions, we don't know how many times we solved. How many times they're asking, I don't know. They are obsessed with these questions, and we have to solve. Those who do not solve this question, I'll be very sad. Those who have attended our classes, if they are not solving this question, then we are very sad. I hope everyone has solved. Okay. Another mold of same material is used to cast a sphere of aluminium having 20 diameter, and pouring temperature is same, ratio of solidification time per same question. They are not changing it, right? So what is that? Case 1, we do the same thing, right? Case 1, this is cube. So what is the side of the cube? Side of the cube is 20 mm. Simple, right? And case 2, okay, this case 1 is cube. Case 2 is sphere. Very simple, right? So the diameter is 20. Simple. What they're saying? What is the ratio? Okay. So first, what is solidification time? Solidification time is given by Sorinus principle, that is equal to K into V by surface area whole square. I was mentioning that you'll forget the square. Do not forget the square. Whole square, whole square, whole square. So what is that? Solidification time of case 1 divided by solidification time of case 2 will be K into case 1 by surface area of case 1 whole square by K into volume of case 2 by surface area of case 2 whole square, right? This K gets cancelled. So we have to individually find what is the volume and surface area of both the cases. So let's do it generically. So for a cube, so this is solidification time of 1 by solidification time of 2, right? So that is s cube divided by 6s square, right? So this is s cube divided by 6s square. So that is what v1 by sa1. And okay, obviously do not forget the value of square, right? And v2 is the volume of the sphere, pi by 4 d square. Sorry. What is this? Okay, this is it is given in d, so I can write this as okay, let me do one thing. I'll write in terms of d only, then this will be pi d cube by 6. Okay, because we are thought of in terms of radius, but this will be pi d square whole square. That's it. Whole square. Square is, you should not forget square. So here this is cancelled. This is cancelled. Pi gets cancelled. Rest of the constants are left. This is s by 6 whole square divided by d by 6 whole square. If we have remembered this, we have even taken some simple geometries and we found out the values of v by sa. If you directly remember, no need to do all these things. Okay, and if you do this, this will be you know, 20 and 20 obviously. So 6 also gets cancelled. So 20 by 20 whole square. So answer is 1. That's it. Simple. Very simple question. Next is in arc welding. Okay. Again, the question is from arc welding. Again, they're asking the same question, repeated question, repeated. Every time they're asking the same question. All of your faculty might have told, please solve previous year questions. Please solve previous year questions. If you have sincerely solved previous questions, you would have not faced any problem. Haram se you would have solved. Okay, the same question they're asking. What is that? In arc welding, V is given, that is voltage. The voltage is 30 and the current is given. The cross sectional area of cross sectional area of welding, I think this is a point. welding is 20 mm square, and welding speed is 5 mm per second. Heat required to melt material is 20 joule per mm cube. The percentage of heat lost during welding process is simple, right? First, you have to find. Let's do one thing. We'll find out what is the heat that is generated. Right? We can just try to find out what is the heat that is generated, right? The percentage of heat that is generated. But how it is generated? Because of melting process. Due to melting process only, the heat will be generated. So heat generated and then heat supply. There are some words that you have to understand, and heat transferred, right? So they're asking what is the heat that is lost, right? So whatever the heat that we are sending in will be used for melting the material, and some will be gone for the outside using the convection and conduction, right? So that is what is your heat transfer, right? So let's find out what is that. So let's find out what is the input that we are giving, heat power, right? Power input power. So the power input power, right? Input is equal to, from our side, that is voltage into I. Or if you convert this V is IR, then it will be I square R, right? Power, so T is not there, right? So then we can write this as 30 into 200, 6,000 watts, right? This is power, please remember, right? And we are writing it watts. And heat required, or heat required for melting, right? HM, how much is this? So this will be what they are saying. Heat required to material is 20 joule per mm cube. 20 joule for 1 mm cube, right? So if you want to find out the volume of welding, you can easily find out what is the volume of welding. The area of cross section is given, welding speed is given. If you multiply area of cross section and welding speed, that is 20 into 5, you'll get 20 mm cube per second, right? Into, so 20 into 5, that is 100 mm cube of volume is present. So 1 mm cube volume is will be requiring 20 joule. So 100 mm will be using this much. That's it. So this is joule per second again is what. So what you can do is you can write this as 2000, right? 2000 watt. So now the percentage of heat lost, right? So what is that? So let's assume that we have total 100% that we are providing. From that total melting, this is 200. So what is input? Input is 6,000, right? And heat required for melting is this much, and rest is gone for the heat loss, that is transferred outside heat loss, right? So this is 100 minus, obviously this is on 200 because we are writing in percentage. So this is 100 minus some 33, 1 by 3, right? Some 33.334, something like that. This will be some 66.65, something like that, or 67, something like that. The answer is this. Very simple. Again, same input output every time there are whatever the question they're asking. This is the same question they have asked, right? Next is what an easy question. Simply, not even 5 seconds we should be taken to solve this question. Of course, reading question will be taking 5 seconds. After reading question, 5 to 10 seconds you should be able to answer this. Very, very simple question. What is that? Allowance provided pattern to easily draw from the sand mold. What will you do? You will do the shaking allowance, right? The shaking allowance is provided. You here and there shake the pattern a little bit, and skill of operator is very important. You should not shake much, right? You should shake a little bit so that you create some kind of a gaps between the pattern and the mold cavity, so that it will be easy for us to remove the material. What is shrinkage allowance? Because we are pouring the material, maybe the material will be shrinked or expanded. Based on that, you'll be able to try to understand the shrinkage allowances onto the pattern by using some kind of material that you are pouring, right? Distortion is because of some cross sections. There is some kind of a distortion because of your heat transfer and because of your thermal gradients and because of the weak sections. Distortion allowance is there. Finishing, because you have some sandy particles that are fixed onto the surface of your molding the final part. What you have to do, you have to do some kind of grinding operation so that your surface finish is good. So for that, you increase your elements. That is what is your finishing elements. Very simple question, right? Seconds only. Next. This also is a very simple question again. If you see the diagram here, this is what I put the diagram. This is what is your iron carbide diagram. Simply, this is the question they've asked. This is the question they've asked. What is that? Perlite consists of. What is the perlite consisting of? Alpha ferrite and cementite. So what is the option here? Ferrite and cementite. That's it. This is the option. Very simple again. So if you have basic understanding, no need to solve big questions. If you have some basic understanding of iron carbide diagram, simply you will directly go and solve the question without any problem. Okay, so that's it, guys. So that's it from my side. Hopefully we'll get the paper from the official gate committee. Then we'll be able to solve all the questions from different sections wisely. Thank you.
Thank you, Mr. Navin, for your, you know, lengthy, continuous support for these solving these all questions. And Rahul sir, so you can tell if you have any further to say on this paper and briefly about any projected rank and all marks versus rank.
Yes, sir. I'm audible.
Yeah, you are audible.
Yes, rank like what we are observing at recently in 2 years, like in 1 year at lower rank we are having the better rank as compared to the uh, past 2 to 3 years. So here it's similarly whatever the 23 rank versus marks pattern happened, same thing will happen in this year also. Maybe
Yeah.
you can expect little better. At lower rank, you may
Yes.
have much better rank than the last year also.
Yes, yes. So that's what I also feel because compared to last year, people are feeling even tougher. Maybe
Yeah. Though
day
the
by
paper is
day.
easy. Yeah.
Yeah, but day by day, students are not putting enough efforts because uh, more the content, more they are getting
Mm.
confused because so much
Confused.
of
Yes.
YouTube contents are there, and where they don't get right mentorship rather than they just getting content. So
Yes.
that's where the issue is there as of now in the learning part. So, and one more thing which is very important for any gate exam is what gate score. So, I believe even gate factor will improve, like score against obtained marks this year. So, so whoever has done better than others, they will be winner, and in the end, and that's what I can say.
Yes.
Yeah. So fine then, we can wind up this session and we will meet it. We will meet again once response sheets are out by 15th of Feb, and then we will solve subject wise, solution for each and every question. Yeah. So
Yes,
thank
sir.
you all watching for this session. Thank you Rahul sir for your insights,
Yes,
and
sir.
thank you Navin sir for supporting solving these questions. Yeah.
Thank
Thank
you.
you all.